Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math Module 3, Lesson 17, Drawing the Coordinate Plane and Points on the Plane. Now there's two big things we're going to get out of this particular lesson, and I think the video will be fairly short, but there's a couple things you need to be able to get out of it. One, you need to be able to draw your own coordinate plane, and most of the time, if not maybe even all the time, you'll have some kind of grid paper that you can work with, which will make that an easier task. However, we also need to decide what the scale of the plane is going to be. So let's take a look here. First of all, if you ever did have to actually draw your own coordinate plane, that's a really hard thing to do, being honest with you, because especially on like a blank piece of paper. But the one thing I do want to show you is that when you draw your x-axis and you draw your y-axis, make sure that you have these arrows so you can tell x and y, and go ahead and label those. And then as you create the rest of your lines, you want to be as straight as possible, and you don't want to cram them together. Even if you need to use another piece of paper or use more space or whatever the case may be, you don't want them to be so crammed together that it's hard to see. Like if you try to do them like this, right? Well, then you kind of get this stuff right in here where they get so close together you can't even really see what's going on. So it's not impossible to draw your own grid, and that's just obviously a really fast one, but it's not an easy thing to do. One thing that you could also do to make life a little easier on yourself would be to draw, obviously better than what I'm doing right now, but draw the x and y axis in a different color, so you always can at least know where to start, where your origin is. If you're going to go 3, 2, right? 1, 2, over 3, up 2, and mark that spot. It's kind of easier to do that if you can find the origin and find the x and y axis. But most of the time you'll have something that maybe looks like this, which is a grid. Now this is actually giving you a quadrant, or coordinate plane, gives you all the quadrants. But if you just had paper that looked like this, you could still easily make a coordinate plane. Again, big things to notice here, they've used a bold line to do the x and y axis. If you didn't have like a Sharpie or a thicker marker, you could just use a different color. They've labeled the x and y axis. And if you have a ruler or a straight edge, something where you can make this line, that's about as unstraight as you can get, but you want to make this line as straight as possible, because if you're going to have to create your own coordinate plane, you want to make it look as good as possible so it's easier to do the math. Now, the next thing we might look at would be to say, like in this one, we have our origin here, right in the middle, right at 0, 0. Well, then we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. They've given you 14 spots on this particular one. Now, if you were going to say, well, I need to go to space 25, if you had to go 25, 10. Well, you can't go over 25 when you only have 14. But what you could do, I'm going to see if I can increase this a little bit. What you could do, instead of saying 1, 2, 3, 4 and labeling them that way, you could actually label 5, 10, 15, 20, 25, 30, and then going up, of course you'd have 5, 10, 15, 20. You could count by fives. And that's called using the correct scale. Like 25, 10 is not going to we're not going to be able to do that if each of these are just 1. Can't do it. But if each space indicates 5, then you can go over to the 25, you can go up to the 10, you can mark your spot, you can call that point F or whatever point it may be, and there you go. So you kind of have to know what scale you want to use. A lot of times each space will be 1, and that'll be fine. But there are going to be times when you're going to need a bigger scale. And there will also be times when you may need a smaller scale. And as long as you have that labeled, you can do that. So let's say we needed to do 0.83 as our next coordinate, our next point. Well, 0.8 is less than 1. But what if, of course, we have 0 right here. What if we had 0.1, 0.2, 0.3, 0.4, basically tenths, right? 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 11 tenths, and keep going that way. What if the x-axis was divided into tenths? So here, you have 0.9, and then here you just have 1 whole, right? 10 tenths. You can also, so you might think, well, but if you have to go up 3, like you're going to have to go up 30 spots to get to 3 tenths. And to that I would say, not so. You can have your x-axis be in tenths, and you could have your y-axis still just be, every space is a whole number. 1, 2, 3, 4, 5, 6, 7, 8, etc. You can do that, absolutely. Label it that way. Make sure it's really obvious. So then we would go over 8 tenths, or 0.8, which is here. We go up 1, 2, 3, and then we make sure to mark our spot there. Maybe that's spot B, or point B, I should say. And there you go. So you can play with the scale and make it whatever you need to be. There are going to be times when you're going to for sure need to do that. Sometimes they'll give it to you. Oftentimes they'll give you a scale or give you something to work with. But if it's a case of, hey, I need to figure out where something would go without necessarily being given the coordinate plane, you can create your own, and you can create the scale that's appropriate for that. We'll talk more about this together in class and go through some different examples and ways to do this and go from there. So thank you for watching, and I'll talk to you soon.